5,
4,
3,
2,
1,
go.
Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm David Southworth.
And I'm Josh Barker.
Coming up today, earlier this year we discovered a whole load of moons of Saturn that we had never seen before. But why didn't we see them earlier, and what are the challenges of finding objects in our solar system? And following a demotion of Pluto, will we ever find a ninth planet? We delve into the mystery of Planet X. So, space wows. Now, our space wows are maybe slightly different from usual this week. Often our space wows are things that make us go, wow, amazing things in space. This is more of a kind of a, wow, what have they been up to this time? Now, Josh, one day we will record one of these podcasts and not talk about Donald Trump and Elon Musk.
It doesn't feel like that at the moment.
Well,
does
yeah,
it?
today, unfortunately, it's not that day because we are going to delve into that world one more time. We've talked about them a couple of times already. Now, people may have seen in the news recently a bit of a fallout. I think it's fair to say the bromance is dead.
Yeah.
So I'm going to just do a very brief update for people about what's been happening, and then we'll see where we go with that. So essentially, Elon Musk has left his government post. That was some parts of the media have portrayed that as a kind of a sacking.
I think it was predicted though, wasn't it?
Yeah,
Right?
he was for the status of employment he had. It's a 130-day limit.
Yeah.
Obviously, with Trump, you're never quite sure if they're going to try and extend that. There is some chat that he had caused some problems and that maybe they wanted to push him out. He wanted it extended. They weren't keen to do that. Either way, it was essentially planned that he would leave the post. However, once he left, he then laid into Trump with both barrels. As ever with these two, they conducted their arguments on their own social media platforms. So there was a tax and spending bill that Trump is trying to push through. Elon Musk doesn't like it. It's going to add, I think I've read a figure of $2 trillion to the US budgetary deficit.
Familiar, yeah.
A huge amount of money either way. And Elon Musk absolutely panned it on Twitter. On X, it's called these days, isn't it? He described it as, I'm going to read this, he described it as a disgusting abomination. Not mincing his words. And there is a suggestion, we talked about conflicts of interest. Part of it is a cut to subsidies to the electric vehicle. I think it's a tax credit. So who knows, maybe that's part of it. Anyway, as you'd expect with those two, it then went back and forth. Elon Musk said he wouldn't have won the election without me. Trump then came in. This is where it comes into space. He threatened to cut all of the US government's contracts with Elon Musk and his companies, which would, of course, impinge on their ability to take people to space. Elon Musk came back and said, fine, I'll immediately decommission the Dragon spacecraft, which is NASA's primary way of getting currently to the International Space Station. And thankfully, at the time of recording, they do both seem to have pulled back from that position slightly. So currently it looks like things are going to carry on as usual. There's an old saying, a week is a long time in politics. Who knows where we'll be, even in the few days between recording this and release. But currently, it does appear that we should be still on track. We think they've calmed down a little bit from their playground spat.
Yeah, it did seem to escalate quite quickly.
It really did, yeah.
It was, quite dramatic. It was almost hour by hour.
It was.
We were seeing huge changes to space strategy and what might be going forward.
Policy made on social media.
Yeah, which is a slightly worrying thing. And I think it really highlights kind of the problem with almost that single point of reliance, like you mentioned.
Yeah.
SpaceX really are driving a lot of what NASA are doing. It's a lot of the commercial resupply. They're taking a lot of people to the International Space Station for the research, but also they have a lot of contracts with the military for flying military satellites and providing. I think they're providing the Starlink network. They're providing their own custom version for the military, and I think it shows that they're two very linked. And then all of a sudden, these things can very rapidly become a problem, and I think that's a bit of an issue which has been interesting to think about.
And that's true with any single company. I think with particularly these two individuals, they are quite volatile. They are not, let's be as polite as we can. They don't always act in perhaps the most mature way. These things are not always done the way you'd hope government policy, government contracts to be dealt with. Maybe once again, it's perhaps best that we leave it there. So the update is they fell out. There looked like it would be a risk to NASA's ability to take people to space. We think currently it's going to be okay, but watch this space. So on to our first topic for this episode. Today we're going to be talking about Saturn's moons. Now earlier this year in March, a whole load of extra moons were discovered. I think it was 128 moons. Now that brings Saturn's total moons that we know about to 274. And I suspect there'll be more to find in the future. Lots of these are very small. So, Josh, my first question to you, why are we still finding moons of Saturn? Why have we not already found them all?
Well, you're quite right. We find them all the time. It's amusing that we're talking about this story now, but if we went back a year, I think there was another 50 discovered just last year.
Yeah, so a couple of years ago, I think it was,
we're constantly finding them. I think ultimately it's because a lot of them are quite small.
Yeah.
They're not very bright. They don't give out their own light. They're reflecting light from the sun, and they're still quite a long way away. Saturn is relatively close in the universal scheme of things. It's within our solar system, and it's certainly not the most distant planet, but it's still a long way away. It's still, billions of miles away from us, and that makes it difficult to see these things.
And we are finding these with telescopes from Earth, aren't we? We're not.
Yeah.
This isn't spacecraft going out there and finding these. It's telescopes. I think it was based in Hawaii. The telescope that discovered these.
Yeah, it's ground-based telescopes that are doing it, and that's because that provides long-term study, which is often what's really helpful when finding these things. It's not just going out deep and taking a picture and there they all are.
Right,
it's often a long-term.
We're comparing exposures of the same part of the sky, or I think it's adjusted, isn't it? So we're following Saturn.
Yeah,
we compare over several days and probably months.
Yeah, or years in some cases. That's right. Yeah, we're looking for things that move. So specifically, you take a picture, and most stuff will move very similarly. So even though the stars move, if you sat out at night and watch the stars drift across the sky, everything moves at a similar rate, except things that are much closer, like planets and moons, and that's how we spot them.
Okay, and I believe the process is once they're found, once they're spotted in that process you described, we then have to go through a whole series, I think a couple of years generally, of observing the path of these moons, making sure their trajectory actually does qualify them as moons of Saturn, that they're not just happen to be going past in that image. We're making sure, so we're observing over a long period of time to confirm their moons, and I think only then they're confirmed as extra moons, which I think is why we got so many in one go.
Yeah, and it's often why we get them in batches, because although we announced these moons were found, back in March, they've probably actually were discovered a couple of years ago, like you say, and that's because we need to verify they're out there. The space, we have this reputation of being empty, but actually it's still quite full of stuff. There's a lot of bits and pieces, dust and rocks of various sizes, asteroids and comet bodies, all this sort of stuff floating around. And yeah, when you find these small, very, often very small rocky objects, is it an asteroid that happens to be in the area? Is it a comet that's drifting in from the outer solar system? Or is it a moon that's connected to this planet and surrounding it? So yeah, we have to watch for many years to establish that yes, it definitely is, it's following the right path, and therefore we can call it a moon rather than something else.
And you talked about how small these are. What are we talking about? I think I saw we down to about 2 kilometres in diameter, that kind of size for a lot of these new ones.
Yeah, I think I've even seen some that are a little bit smaller. I think the smallest one I saw on record was about 600 metres across, which is
even
absolutely
the ones
tiny.
Confirmed now as moons of Saturn.
I think so, yeah. So some of the smallest ones. But, they're also quite big. Famously Titan, Saturn's biggest moon, is bigger than the planet Mercury. So these things do range in size, but what we tend to be finding nowadays are small, tiny space rocks.
Because they're the ones we've not managed to see previously.
Yeah.
I actually got some numbers down for this because I knew we would talk about the relative size of the moons. So I'm going to be quoting my research earlier. So of the 274 moons of Saturn, I believe that 24 are what we would tend to term regular satellites.
Right, okay.
So that means they're a reasonable size. They orbit roughly in the equatorial plane of Saturn, and they go anti-clockwise, prograde, the same direction as most other things go.
So that's similar to like the moon of the Earth, right?
Exactly.
Sort of roughly along the same line.
Precisely, it's slightly off, I think, but yeah, roughly in that equatorial line, which suggests they were probably formed when the planets formed in the early solar system. The other 250 or so, smaller, they generally orbit a bit further out, and they generally have quite eccentric orbits. So they go much further out from Saturn. A part of their orbit come further in at one side. They're on different planes, so they're not necessarily in the equatorial plane. So I think there's generally three ways that moons can be formed. One is out of the circumplanetary disk, with the formation of the planets.
Yes, that's all the material that's left behind once the planets form, sort of the debris almost.
Precisely. So those major moons we think are probably formed like that. The second one is collisions, when something smashes into something else and bits are left over. Some of those can become moons, and then captured asteroids. asteroids that might have been flying past but then brought in by the gravity of a large planet like Saturn. So it looks very likely that those other 250 or so that we currently know are of those latter two
Yeah, I
categories.
think so. And I think I was reading a couple of studies that were saying they were looking at some of the bigger moons and thinking that collisions could be a big part. So one of the big mysteries of Saturn is actually, we don't know where its rings came from. We've got these beautiful rings, but we're not 100% sure what they came from. And so we think that, collisions might be what we're seeing. And rather than being, separate individual little special moons, it's probably actually just, the junk and the debris left from perhaps some rather dramatic collisions that happened. In fact, I think one amazing study I saw positioned even some of Saturn's largest moons as quite young. Now, I say quite young, they estimate to be around 100 million years old, which is old for me.
Am I right in saying the rings of Saturn we think are around 1 million years, or have I got that vastly wrong?
I think they're also considered to be quite young. And so this study was using material that we'd found that matches some of the material we get right at the edge of our solar system. And so we think maybe something drifted in from there, smashed together, and what we're seeing is sort of this almost rubbish heap of material that's been left behind rather than, like say, formed with the planet. Yeah,
absolutely. So having lots and lots of very small objects does kind of tie in with that hypothesis that it's collision, that something broke up in essence. We've mentioned the rings there. I want to talk about what actually counts as a moon.
Okay.
Because we're talking about tiny chunks of rock. I thought down to 2 kilometres. You said some of them maybe even smaller. I know they've discovered things they call moonlets.
Yes.
Some of those within the rings. We talk about shepherd moons in Saturn, where the gravity from those moons helps to keep the rings in a stable orbit. I know they've found some moonlets which get very, very small. And that brings me to what I find quite a difficult bit of classification, because some of the sort of size we're talking about of these little moonlets, they're down to kind of 50 or 100 metres. Now that's far smaller than some of the chunks that make up the rings of Saturn.
Yep.
So why, the moonlets are not categorised as moons. They do have this separate name, moonlets, not fully defined. None of this is fully defined. But why aren't the chunks of the rings, all the little tiny chunks of rock and ice, why don't they count as moons?
Well, I think you kind of hit the nail on the head. The big question is that they're not formally defined. There is not an official definition for what is a moon. It is, this thing that's this size in this position. We know that generally they're natural satellites, so they must orbit a planet or another object. We've found moons around asteroids and other objects that we find out, and dwarf planets, of course, yes. But there's no real official definition. And so at some point, there's a group of scientists that come together fairly regularly called the International Astronomical Union, the IAU. At some point, I imagine they will have a big meeting where they'll all get together and say, right, we need to figure out what a moon is. What do we classify? Do we need extra things? Do we need these moonlets? Do they need to be a separate official thing? Because they're not really at the moment. They're sort of just a name we give. But that decision hasn't been made yet. And so at the moment, is it a moon? It's going around a planet, so maybe.
Well, I want to talk about that a bit more. Before we move on, I just want to, one more thing. All these small moons we've discovered.
Sure.
Now, the naming process for moons of Saturn, most of these new ones, we should say, don't have names. They have kind of code numbers. But the naming process for moons of Saturn, they're named after giants from mythology. Greek mythology, Norse, Inuit, I think some Celtic mythology. Quite ironic if some of these smaller ones start to get names after giants. However, let's move on to the IAU, the International Astronomical Union, because this has a nice tie-in with the way they dealt with Pluto.
Yes.
Pluto was for a long time considered the ninth planet, discovered in 1930. There was always argument about whether it counted as a planet. And in 2006, they did come up with a definition, and that led to it being downgraded to be a dwarf planet.
Very controversial.
Absolutely. And I think we may touch on that in our second topic as well. But should something similar happen with moons? I think from what you said before, you think it should.
I think so, and and maybe that plays to the scientist in me, in that we like to have nice, clear definitions as to what is X and what is Y and what are these nice, neat categories. And life's messy; it doesn't always fit into nice, neat categories, but it does sort of help us understand and give us an idea of what we're talking about when we consider certain stuff. So I think it's probably fairly inevitable that at some point we're starting to get a bit ridiculous.
Especially if we find even smaller ones. If we find another 100 moons next year.
Yeah. When do we stop? And you're quite right. If we find a chunk in the rings that's above a certain size, well, should that be a moon? And do we need to add another 1,000 for those, or another 1,000,000 perhaps?
Yes.
Well, probably not. It starts to get unwieldy.
Now, we haven't got too long left on this category, but very briefly, I'm going to put you on the spot. Any thoughts on how we might categorise them? How we might choose to downgrade something? What counts as a moon and what doesn't?
I think it's really difficult. So obviously with the planets, we picked things that were spherical and things that had we cleared their orbit. And I think that comes into the moonlet definition, is that if you've got lots of stuff around you, you're a moonlet, you've not cleared your orbit. So I wonder if it'll come down to that. I think...
But then we can't use the hydrostatic equilibrium, the spherical nature, because loads of moons,
they're
Phobos and Deimos, the moons of Mars, it feels like they should remain moons. They're very small, 20 kilometres one of them, and I think 12 kilometres the other.
Yeah, I think ultimately this isn't going to be a clear cut, which I think might be why they've not made an official ruling yet, because I think ultimately we're just going to have to say maybe a moon is anything above a kilometre, and that'll just be almost an arbitrary, randomly selected line, but it neatens and categorises everything. But maybe that's why they haven't made a decision, because there's not something that clearly is a moon and something that clearly isn't a moon.
Well, we should probably move on. Just briefly before we do, my thoughts. I wonder if they could do something to do with maybe the proportion of the mass that's orbiting a planet, and it has to be above that a certain percentage.
That
maybe
could
something
work.
Above, I don't know, 0.1% of the total mass counts as a moon. That way you can keep Phobos and Deimos as moons. I don't want those two downgraded.
Maybe that's the big controversy. Pluto first, then they come to Phobos and Deimos. Yeah.
So for our second topic today, we're going to be talking about the mysterious Planet X. Does it even exist? It ties in actually with Saturn's moons, finding things that we can't really see very easily, even within our own solar system. So, Josh, perhaps tell us a little bit about the current thoughts on a search for a mysterious Planet X.
Yeah, so this is this search for what else is in our solar system. Like you say, a bit like the moons of Saturn. There might be stuff lurking out there at a distance, at the dark, that we don't get to see. And Planet X is one of the big candidates for that. And in fact, it's not all that new. We've been suggesting that there might be an extra planet for around about 100 years now. And that's all because our solar system doesn't quite work in the way that we expect it to.
Okay. So, yeah, I mean, I know more about the previous searches for a ninth planet. I think you probably know more about the current one. So, I mean, this comes back to Neptune. Neptune was discovered because it was predicted, and its location was predicted because of eccentricities, anomalies, if you like, in the orbit of Uranus.
Yeah, that's the orbits. So the planets all affect each other. Gravity is this great force that affects everything. And we looked at the orbits of the planets, and it didn't make sense. The way that we saw some stuff moving before we knew that Neptune existed, we were like, well, the only way to explain what we see is that there must be this other giant planet out there pulling on the planets.
Yes, and then some scientists looked at this in the mid-1800s, I think, isn't it? They did some very detailed calculations and quite accurately, I think, predicted where this eighth planet, as it was then, should be. And pretty soon afterwards, Neptune was discovered.
Yeah, and I think that's a really, really good example of science at its best. Science is all about figuring out what we know, making a reasonable understanding of how that's going to work, and then using that understanding to make a prediction. And you hope, if you've got everything right, that prediction comes true. It turns out in Neptune's case, we saw an absolutely textbook example of understanding, figuring it out, predicting, and realising we were correct.
And then a slightly less textbook example was the discovery of Pluto, because the same kind of process was going on. There was a guy called Percival Lowell at the early 20th century. He did the same thing. He saw some eccentricities, some anomalies in the orbits of Uranus and Neptune, I think, and predicted another large planet beyond that. And that led to the discovery of Pluto. But kind of by coincidence, it was later realised that Pluto is far too small to have had the effects that were predicted. So it was a nice coincidence that we found Pluto like that, but not quite as accurate predictions in that case. Yeah,
that was the case. And I think Pluto came as a bit of a disappointing surprise, which feels really mean to put it that way.
Yeah.
But they were expecting this big planet, and Pluto was there, and they suddenly realised it was nowhere near big enough. And that sort of, for a while, sort of ended this idea of Planet X. Maybe we needed to understand something else about the solar system. We had started to discover lots of objects out there.
Yes.
So there are things called the Oort cloud, which are where comets come from, and the Kuiper belt.
Absolutely. I was going to say even within that, because when we discovered Pluto, for a long time people thought it was Planet X.
Yeah.
It wasn't until much later we realised it couldn't be. And it was the discovery of all the other Kuiper belt objects in the same area as Pluto, I think in the 90s, that led to what we talked about earlier, about the demotion of Pluto down to being a dwarf planet.
Yeah, that's right. It was not quite right. And starting that discovery, but also finding things outside of our solar system and really starting to need that to link that in. But yeah, you're quite right. That sort of ended the Planet X discovery up until quite recently.
Yes. So after that, people started talking about Planet 9.
Yes.
I think the terminology is kind of slightly interchangeable. Am I right?
Yes. Planet 9's technically different. So Neptune, Planet X was supposed to be this Neptune-sized object that then turned out to be Pluto and maybe not. And so Planet 9 was then an attempt to fix that if we'd already got Pluto, we might need a slightly smaller planet. So planet 9,
Okay.
which is not Pluto, which was the 9th planet, it all gets very confusing, bear with us, was actually something that's a bit bigger than Earth. So it wasn't anywhere near as big as Neptune and Uranus, but it was actually around 10 times the size of Earth, a bit closer in.
Right, so they are actually slightly different things. Planet
Yes.
X was an old prediction and potentially a new prediction of a roughly Neptune-sized planet.
Correct, yeah.
Planet 9, smaller, a sort of super Earth.
Yeah, and it was to fix the similar sort of problem. It was these differences that we saw, but it was a different solution. So they were separate up until recently,
Right.
when we've discovered that there may be actually a giant planet out there, and actually it should be maybe close to what we'd expect from Planet 9, but the data suggests that actually it might be as big as Neptune, so maybe it was Planet X.
So it's a bit of a combination of those
Yeah,
two.
it's kind of a
in
weird
theory.
combo of both.
So is there any suggestion that we've found anything that could fit that bill?
So we've definitely, well, not definitely, we think we found something. So this was a study using infrared energy. So rather than light that we see and that we use telescopes, this is more heat energy.
And infrared's the same way that James Webb Space Telescope looks out into the far reaches.
Exactly
universe,
right,
isn't it?
yeah.
Okay.
So this was using a different telescope, using the same energy, but looking a little bit close to home. And they were actually comparing big surveys. There was a huge survey taken in the 80s, and there was a more recent survey, and this team of scientists from Taiwan said, well, if we compare these, we could see if anything's moving.
Yes.
And in theory, if it's outside of our solar system, it should stay pretty still. And if it's a bit closer, we'll see some movements.
So that, again, is very similar to what we talked about with finding Saturn's moons, comparing the same part of the sky and seeing how things move and working out where those things must be.
Exactly the same
Okay.
process, yeah.
Okay.
And that's what they did. So they had a look through and they honed in on, I think they said like 1 or 2 pixels in their data
Right,
source.
yeah.
So this huge section, they noticed this object that was moving, and it was moving at a rate that would put it roughly in the orbit of Planet 9. So they got very excited.
You said it's similar size to Neptune. Do we know how far away it is?
So it ranges, I believe, from about 200 astronomical units. An
Oh, wow,
astronomical
okay.
unit is the distance between the Earth and the Sun. So it's about 200 times further away.
So that would be, I'm going to do the quick maths here. So the Earth to the Sun is about 150 million kilometres, which is 1 astronomical unit. So 200 of those is going to be 303,000, 30 billion kilometres, I think.
About that, and
Let's
without a
let's pretend
calculator
that's
as
right.
well. But it then also goes out to 1,200 astronomical
Oh,
units.
okay. So
it's a
even much
very
further,
stretched
right.
out orbit.
Very eccentric orbit.
Yeah. And so we see this. We've seen this out there. This size and this distance. But it's roughly in where we expect this to be.
Okay.
But the signal that we saw from it suggests it's bigger. So we were all very excited. It could be Planet 9.
Yeah.
Maybe it's about 10 times the size of Earth. And then we looked at the signal and we're like, well, that object wouldn't make a signal that strong. It's therefore got to be about Neptune size, which is
Because
where
if
this.
it's that far away, it has to be bigger to reflect
Exactly
enough light
right.
for us to be able to see it in that way. Interesting. The sort of distance you're talking about, that deals with one of the issues I had with this, which is surely if there's going to be something large enough to be considered a planet at that distance, we come back to the definition of Pluto as a dwarf planet. And the key issue there is it hasn't substantially cleared its orbit. It's too small within the confines of the Kuiper Belt to have cleared up all those asteroids. My thinking was, if something is large enough to meet the criteria that we now have for a major planet,
Yeah.
how come we haven't seen it? Because it would be visible, surely. But if it's that far away, I suppose that does deal with that.
That's the trick, yeah. We see quite a narrow portion of our solar system. Our solar system stretches on for a lot longer than the sort of main planetary bulk, which is sort of to be expected. You expect material to peter out and get thinner.
Yeah.
But yeah, this thing is super far away, and we're not going to be able to see it very clearly.
Now, we're talking about a very eccentric orbit.
Yeah.
So like you said, it goes from, it's a kind of a very elliptical orbit. Now, that would make it pretty different from any of our other major planets. Is that going to lead to another controversy and another issue for the International Astronomical Union to decide whether that does count as a planet, or is that eccentricity going to push people towards thinking, well, this is something different. It's a different kind of object altogether.
It is going to add some interesting questions. We know that planetary orbits aren't circular, but we roughly expect them to be close to circles.
Most of our major planets do a pretty circular orbit, don't they?
Yeah, but I think we might be able to stretch and bend those to accommodate if it's something that fits all the other categories and lines up. So, we're still learning about our solar system. We're still figuring it out.
And presumably one of the criteria, again, coming back to the Pluto discussion, the dwarf planets versus major planets, one of the criteria is the body has reached hydrostatic equilibrium. Essentially, that means it's made itself spherical.
Yep.
Potentially with an object that far away, it might be very hard for us to confirm that, although at that size, it's pretty likely it will have met that criterion.
Yeah, you're quite right. It might be really difficult to get images of this, although we're hoping that there's a couple of new telescopes that are coming online. So the Vera Rubin telescope, which is a ground-based telescope in Chile, is about to start capturing data, and that's about the right size to get some more information about this. We're launching, hopefully, a telescope next year called Nancy Grace Roman. That's going to go up and, again, should be able to see things. So, yeah, it might be difficult to get exact pictures, but you're quite right. The size tells us exactly what we should expect, and the size of this object means it's almost certainly big enough to make it sound spherical.
Yes, if it is that large enough. Excellent. Well, again, we're coming towards the end of our time. It would be remiss of me not to mention Donald Trump one more time. Nancy Grace Roman telescope going up next year. Currently, with the proposed cuts, it may not be.
I think it is in the list. I think NASA's response to the budget.
Oh, they've said they probably are still going to do that.
Yeah,
that's one piece of excellent news about Donald Trump that I wasn't expecting us to manage to finish on today. Thank you so much, Josh. I didn't know a lot about the current search for that extra planet, so that's been really enlightening. Thank you.
Let's see if we can find it.
Now, every week we want to bring you ways to engage with space. We've got 2 of those this week. Josh, do you want to go first?
Yeah, I saw a really cool project called spaceselfie.com, which, as you might guess, allows you to take pictures of yourself in space. So this is actually a project from a former NASA engineer called Mark Rober, who does some amazing YouTube videos on engineering and building projects and getting involved in STEM and science. And he's recently spent quite a lot of his own money building and launching a satellite into space. And the cool thing about this satellite is it has a camera and a phone on it that displays a picture and then sends it back to Earth. So what people can do if they want to get involved is they go to the website spaceselfie.com. You can upload a picture, whichever one you'd like, and you tell the satellite where on Earth you'd like your picture to be taken within the background, submit it, and then once they get around to taking it, they'll send it and email it back to you. You'll have your very own selfie in space, which I think is pretty cool.
That certainly is a way to really get engaged in space. Fantastic. Mine, well, I was going to talk about something that actually happened a few days ago. I don't know if you saw the conjunction of the full moon with Antares.
Yes, I think on Thursday, I think.
Yeah, I think it was Thursday, maybe even Wednesday. I'm not sure.
Yeah,
either way, a few days ago. Antares is a large red star in the constellation of Scorpius. So you may have missed that one. However, conjunctions like that happen all the time. Quite often, the moon with a planet. It's when 2 objects line up very close in the sky. So keep an eye out on our Stargazing blog. We'll link to that in our notes for this podcast. And that will give you a chance to look out for any events like that in the future. Now, that is all we have time for on this episode of Space Now. Thank you very much, Josh.
Thank you.
And thank you all for listening and for watching.
And remember, if you have questions or space topics you'd like us to discuss, then send them in to podcasts@spacecentre.co.uk.
Space Now will be back next Friday when Dara and Ed will be back. They're going to be sharing an update on the NASA mission that's heading towards the sun, or as the headlines would have it, flying in to touch the sun. So make sure to tune in to find out exactly what's going on with that. Also, please make sure you're subscribed to Space Now in your podcast app. Catch up with their analysis and also make sure you never miss a future episode.
And if you're enjoying listening to the episode or watching the episode with us here today, please do share with your friends. Word of mouth is such a great way to get more people listening, more people understanding what's going on beyond the headlines, and more questions for us to answer and talk about. So do share and we can spread space together.
That's all from us. Thank you very much and see you soon.